Okay, aloha and good evening, everyone. Thank you so much for participating. And we're so fortunate to be able to be here at Oceanit, and Pat Sullivan and his team are here helping, and the project manager from Herzog from the Army Corps of Engineers will be joining us, and someone from Senator Schatz's office has been invited, and we're looking forward to all working together. And we do have our permitted interaction group here, Councilmember Carol Fukunaga and Councilmember Tommy Waters. We're really hopeful that we're going to come out with this wonderful plan. And we have about 20 members of the community joining us, because that's the only way to do things, is in a transparent manner and working together, because we're hoping to come out with a really wonderful plan for this whole area, one that where no one really suffers and everyone benefits. And we're depending on Oceanit and their crew and everyone to have input into this project. And working together, Councilmember Fukunaga and Councilmember Waters and I are very hopeful that we'll be coming out with at least a draft this evening. Thank you. And now Pat Sullivan will be here to share his thoughts.
Aloha. I'm Patrick Sullivan, and I'm delighted to be here. And council members, thank you for making this happen. And for the people that are attending, thanks for making the time. This is a really important project. I think it's got to be the largest climate project in Hawaii's history. It's a low probability, high impact problem of what happens when there's a 100-year rain event. And the chances of a 100-year event, although it sounds like it's once in 100 years, but with climate changing, the probabilities are increasing. So we just had a near miss with a hurricane, and we could have had a significant rain event. And with that would come a lot of personal suffering and damage and economic impact. You know, the water in the watersheds we're focused on point to under normal conditions, I would say the economic engine in the state of Hawaii, but it's still, whether it's full of tourists or not, it's a special place and it's an important place. So for our long-term well-being as a state, it's really important we do this, and do it right. For those of you that don't know, we worked on a design maybe over 10 years ago, and climate was not an important issue. Today it is an important issue. However, our role is a little different. We're not trying to design a solution, we're trying to enable a solution. And we're really delighted to hear from the community. We've heard from lots and lots of people and their issues and their ideas. And then we've had opportunities to collaborate with the Corps. Corps of Engineers is the federal agency that really is in charge of these major kinds of flood projects. And they're trying to work with the community too and listening very carefully. I think the issue is trying to make sure we're all communicating and working together, because it's in everybody's interest to have a good solution that allows the community to thrive and yet be protected. And there's been a lot of really interesting things you're going to hear about today. I think some of the ideas have kind of come together with a few design concepts which look promising, which could enable the community to have the benefits they want with the safety and protection that everybody wants as well. That's not an easy thing to do. And then I think overall then the idea is to get all of us working together to see how to implement these things, provided that it all continues to make sense at each level of examination and the process. So anyway, I want to thank everybody that really is here today, that's worked hard to get here. This has been a long conversation, and long, I mean the flood mitigation for the Olawai watershed is something that's been discussed for a long, long time. And it's such a blessing to have federal funds to augment the actual cost, because it is a really expensive problem. So we want to make sure we don't take any of that for granted, and we keep working toward a solution that works for everybody. So anyway, I want to thank everybody again for making the time. Thank to the council members and the PIG, as it's called, but there's a public interactive or private interactive group, the PIG. People have been working really hard to not only listen, but then put those thoughts into action that will ultimately result in a really good solution. So thank you, and you're in for a treat as you hear more about it. So aloha.
All right, thank you, Ben. Good evening, everyone. This has been a long trek, and like they were saying, we're under some very trying circumstances, and we're going to be doing this with COVID being around. But I think, you know, at Oceanit here, we just kind of go back to work as normal, but we institute all the distancing and the safety protocols so that people are safe, and we just kind of carried that on with this project. So yeah, so 4 things that we're going to talk about this evening is, the first one is the status of the work that we have done for the PIG. We're going to talk just a little bit about the Corps' engineering documentation report that we call the EDR. And then we'll talk a little bit about what the current state of the original EIS is, and then the next steps for this project. So with that, brief history. The Corps released its original feasibility back in 2017. And as I think most of you know, the community strongly objected to this feasibility study. And specifically, they did not like the flood walls, the detention basins, and more than anything else, the condemnation of private property to create these detention basins. And the Corps actually took this to heart, and based on this community reaction, actually began to look at the objections and began to make changes to this feasibility study. Now, this is where the PIG actually hired us at Oceanit to start out doing community outreach. And we started that back in August and September. And when I was looking at this, I was just amazed. That's been about a year that we've been working on this. And so here we are today at a major milestone. Some of the things that the Corps did in making their changes was they shifted their model from one of a detention basin to one of a water conveyance, meaning that instead of trying to capture the water at the basins in the upper watershed, they were going to run them down the mountain toward the canal. What that did, though, is it put more water in the middle and the lower watershed, and actually resulted in some water accumulation in the Mo'iliili-Macaulay area and in the UH area. And we were able to verify this with the HEC-RAS computer models. And I really want to say that we are very grateful to the Corps for sharing their models with us. And that's how we were able to run some of these models. And so what we looked at was the model with no features, and we saw where the water was going. And a lot of it was accumulating in the lower watershed. Now, along with that, we talked about ecosystem restoration. And I think a lot of you were involved in this. And what we were trying to do, and the Corps was trying to do this as well, was to generate ideas of ecosystem restoration that could be done in conjunction with this project as we moved along. Some of them were connecting the Kapahulu end of the canal to provide water into the canal so that there was some recirculation. installing a network of sensors throughout the watershed and 3 streams to provide feedback on what was happening, implementing a microorganism technology study. And I think a lot of us saw this with the Genki LOI project where they were trying to reduce the levels of sludge and improve the quality of water. Another one that was tried was, and that they're still looking at, is harvesting of the albizia trees in Manoa to reduce the sources of the debris coming down. And it's not just, we're going to raise, knock them down and then have to dispose of them, but they were talking about using wood as lumber to possibly build things. And then another one was installing oysters and clams as living filters to improve the water quality. So those were some of the ideas that have come up, and we at Oceanit, as well as I believe the Corps, continues to ask people for ideas on what they can do in this area. You talk about SWIFT, which we came up with as a name. We call it the Subsurface Watershed Inundation Flow Technology. Again, we call it SWIFT, but basically it was a result of the community meetings that we had over the past year. We had 13 meetings, and we had over 300 people that attended. And what happened was, as we were running the models, the HECRAS models, and noticing that there was a lot of accumulation of water in the lower watershed, the PIG asked us to see if we can address this accumulation of water and come up with something that would help relieve that problem. And so that's how we came up with SWIFT. And really the objective was to utilize tunnels to remove the water from the upper watershed, bypassing the lower watershed and the Alawai Canal, and discharge directly into the ocean, thereby not allowing the water to build up in the lower watershed. Now, the one thing I do want to say is SWIFT was not intended to be a comprehensive solution in lieu of everything that the Corps has done. It is actually to help address the excess water accumulation in the lower watershed. And I think some of you have seen this before. This is a kind of a cartoonish diagram of what the concept of SWIFT is. And we like it because it easily conveys the idea of what we're talking about. And basically is up at the higher levels, we would build a tunnel that would allow water to drain and go under the ground all the way to the ocean. And in the case of SWIFT, we're talking about a 12-foot tunnel. And that would be somewhere around 40 feet under the ground and go all the way to the ocean. All right, so let me talk about what SWIFT is. Basically, the design is 2 tunnels, one in Manoa and one in Palolo. We originally had one in Makiki, but Makiki did not generate sufficient water to actually cost justify having it there. And actually, the one in Manoa actually takes care of the drainage for Makiki. And what we did at Oceanit was we contracted actually 2 firms to give us a high-level conceptual design and a cost estimate for SWIFT. And the first one that we got was done by a local company, and we wanted to try to, as much as possible, keep things local here because the local people understand, the problems that we face here. Unfortunately, I believe they were competent in being able to do this, but they had never done tunneling to this scale before. And so they came up with an estimate that included a lot of contingencies because they just didn't know what they might run into. So what we ended up doing was going back to some of the things that we at Oceanit have done in the past. We have an oil and gas division that works out of our office in Houston, and they do a lot of work with companies like Shell Oil Company dealing with moving oil and gas. And so while we don't design or build tunnels, we worked with people that do that. We actually do the coating on the insides of these tunnels. And so we actually knew people that could do this. And so we actually got a recommendation from our people in Houston. And lo and behold, the company that we got actually built the Kailua to Kaneohe sewer tunnels that actually go under parts of Kaneohe Bay, and they did this very, very well. And I really want to mention that because this project, you know, it just kind of hopefully tells you that this is not pie in the sky that we had come up with. This was something that has been done before, and the city has done it, and I'm happy to say that it was built, it came up in 2018, and it was on budget, on time. So I want to just show you a few pictures of what this Kaneohe Kailua tunnel looks like. So actually you see on the map up there, the area up in the upper right is around Oniava Street in Kailua. This tunnel is a 10-foot diameter tunnel, and it goes about 3 miles underground. And it is about 35 to 65 feet underground, depending upon the mountain terrain. It took 13 months to complete at a cost of $375 million, and it was actually put in operation in 2018. And so again, this is something that the city is familiar with, and you can see pictures of the actual tunnel itself and what the inside of the tunnel looks like. Okay, let me take you back to Swift. So we are thinking of very similar tunnels. There are 2 of them. One of them coming down from Manoa out to the ocean, and the other one in Palolo. Now you might ask, okay, where does it start in Manoa? We don't really know exactly. We have a preliminary design, and we were thinking that it would be somewhere near the Woodlawn Bridge, actually near Noelani School that would start, but it can change. But that's just a marker that we put in. In the one in Palolo, it's at the intersection of Palolo Avenue and the Palolo Stream. And again, that's just preliminary. Well, it may change. And again, I don't think it's, the exact area is not important right now, but when you go into the detailed design, I think it will be. Okay, what's the cost? Well, our first estimate came up to be about $581 million. And again, this was a local company. They put in a lot of contingencies. Again, that's what it was. We came back with an updated estimate. Again, this is with the company that we had experience with it in Houston and had actually successfully managed and helped construct the Kailua to Kaneohe tunnel, and they came up with about $262 million. Again, a lot less. It's less than half.
So what about the flooding in the Macaulay and Moiliili area? Is this going to help alleviate that, or just water that's coming from the upper area? Sorry.
Well, there's a lot of water coming down from the upper watershed when we ran the models. When we modeled the Swift tunnels, it significantly reduced the amount of water there. And so what we're really interested in seeing at this point is, you know, where the core is at, and what are their features doing? Because I think in combination with what they're doing and the relief of the water coming down to the lower watershed, I think we should see a lot. But right now, Sydney, I don't know what the answer is, but we do know that Swift takes a lot of water out of the system.
And would this remove the dogleg that the Army Corps is talking about putting under Manoa Marketplace? Would this alleviate that?
Again, I don't know, because we don't know a lot about the details on that. We don't have the EDR, and we don't have the models with the EDR. And so really what we would like to do going forward is, when we can get our hands on it, we would take the Swift system and drop it in on it and see what happens.
Okay. I guess my next question is, since the Army Corps has already put in the EDR to their head office, are they going to be able to incorporate this if this is something the community decides they want? I guess maybe that's a question for Jeff.
Okay, that's something for Jeff to answer. again, there's going to be a lot of discussion about that going forward. We just kind of want to present what we have right now. It's been a while since we've talked to all of you. And yeah, again, that's coming up next.
Can I ask the mechanics of that? Forgive me, I'm not an engineer, but how would the water drain into the ocean when it is below sea level? Would you have some sort of forced main on it? And what would prevent it from, assuming it were around, say, Noelani, where you had a lot of debris accumulating? How do you, I suppose you have some design in mind that would stop trees and boulders and dirt from clogging it up. And the other part is, and I think you're probably getting to this, are the other elements that you looked at as well, that may include walls or dams or other pumps and that sort of thing. Is that correct?
Yes, and let me turn it to Steve so he can answer.
Okay. So first question, how would we prevent boulders and
the debris
and all of that from getting in the tunnel? So basically what we're doing, we've designed it to where we would put a weir in the stream. The weir would serve as like a siphon, if you will. When the storm level gets to a 20 to 25 year storm, we would siphon the water off. We'd send it through a maze so that we would not end up taking logs and sending them over there. When it comes out of the maze, it goes into the tunnel. There's a grill on the top of the tunnel that keeps the debris out. And it would end up coming down underwater. It's been designed to where we're tapping in from up on the upper watershed, and we're not using any pumps. We have the tunnels coming down to an outfall on the shore. The outfall then goes into 3 microtunnels that go out into the ocean, 2,000 feet out, and discharges at a 40-foot depth. There's a flapper valve, if you will, in the outfall that prevents the water from coming back. And the tunnels are only used at the point where we have a storm that's above a 25-year storm. We siphon waters off, otherwise it's dry. We have no moving parts, so we don't need any pumps. Because of the elevation at the point where the tunnels are located, the head of the water would drive the water down through the tunnel, so you don't need any pumps. And it would drive it down to the point where it would come out through the flapper valves, and at the point where there wasn't enough pressure, the flapper valves would close, the water wouldn't backflow, and the tunnels would stay dry until the next storm.
I see. And then about the other elements that you may have looked at, including pumps or walls or dams or anything, will you be getting to that later? Or is that included inside of this?
Well, we started looking at it, but the goal initially for this project was to find a way to address the excess water coming down from the upper watersheds as a result of removing the detention basins. So the design of the SWIFT tunnels are to address that specific issue. You might ask why do we still have water in the lower watershed? We're not removing all of the water. As I said, we're siphoning it off at the point where we have a 20-year storm. Otherwise, we let it go through so we don't end up impacting the wildlife and the natural flow of the tunnel. But when we do have a storm event, then we siphon it off and it goes down. In terms of other features, we've looked at some of the other features that the Corps has started to talk about, and we want to integrate with that, but we want to wait to get the models so that we can go ahead and integrate the SWIFT tunnels with the Corps EDR solutions to identify what we view as an optimal solution with some elements of theirs and the SWIFT tunnels, and we'll be able to show you results at that stage.
What I'd like to know is the relationship between this particular project and the EDR. So what was Oceanit's understanding about the timetable? because the Army Corps is set to release its EDR. Well, it was set to release it this month. They're a little bit late, perhaps. Why was the timetable the way it was? Because once the EDR has been worked on and approved by Washington, it seems like the train has left the station, and this plan is a little bit late.
The Corps locked down the features for the EDR before the SWIFT tunnel idea had been introduced. So you're right, the tunnels, SWIFT tunnels are not part or will not be part of the scope of work that's being released in the EDR. We've talked to the Corps about this. They're willing to consider it as a value engineering study or possibly as something, a betterment that they could include in their NEPA. And the city is looking to take this on themselves and to champion or push through the state EIS so that we could work both projects in parallel.
This is Chris Tipton in Makiki. I had two quick questions about this current slide. What happened to the third tunnel in Makiki, and what was different between the initial and updated estimates that the updated one is half?
When we originally had the three tunnels there, one of the things that we noticed in the computer models is it didn't make that much difference. And so when we modeled it without it in Makiki, and actually we kind of picked it up in Manoa, there was really no difference for Makiki. However, it did add significantly to the cost. The initial estimate for 3 was about $750 million. And that's kind of why we cut it out, because it really made not that much difference.
So that answers part of it. The other part of it is the estimate that you see now that's half the amount was done by a company that does this for a living. And they were the ones that did the tunnel from Kailua to Kaneohe. And they ended up coming up with a conceptual design. They ended up pricing out all the elements of what it would take to drill the tunnels, do the outfall, do the 3 tunnels, micro tunnels out to the ocean. And they do this for a living, and they're very comfortable with the number that they provided us as this is what it would take from a construction standpoint to build it.
Thank you.
One last question. When did you start with this idea? Was it in May or April, the Swift Tunnel idea?
We started it in about March or April. We had come up with the conceptual design, and then we started working on it. We started discussions actually with the Corps and with the PIG, and everybody was sort of receptive to that idea. Unfortunately, with the Corps, their EDR had already been locked down at that point.
March and April was already locked down, but they just submitted in July. Okay, thank you.
Yes.
Hey, Steve, this is Mike Gelhoff. You said it was a 12 by 12 tunnel. After you talked to the contractor, did it go to a circular tunnel?
The tunnel was never 12 by 12. If you had that opinion, I'm sorry if I gave you the wrong impression. Initially, we looked at a lot of different configurations and a lot of different locations. We ran them through the HEC-RAS models. We determined that a 12-foot tunnel in Manoa was good. A 14-foot tunnel didn't provide the incremental benefits for the additional cost. We were initially going to go with a 10-foot tunnel in Palolo, but when we worked with the tunnel boring company to come up with the estimate, they pointed out that it would be better for us to do 2 12-foot tunnels because they would use the same equipment. They wouldn't have to bring in different equipment, and they could both take advantage of the spare parts and all of that. So it would be actually cheaper for us to do 2 12-foot tunnels. They're actually boring. They're circular tunnels. They're boring 14-foot circular holes in the ground. They're starting on the shoreline and going uphill with a tunnel boring machine. and they're going to pull behind it 12-foot concrete pipes that they're going to hook and put in place. And then down on the shoreline, they're going to build a concrete outfall, and they're going to take the 12-foot tunnel and they're going to put it into 3 7-foot diameter micro tunnels that will be that they'll bore from the coastline to about a 2,000-foot distance offshore to a caisson where they'll retrieve the equipment, and they'll put pipes in there, and the 12-foot pipes will feed the 3-foot pipes, and then in the outfall they'll put the flapper valves to keep the water from coming back when there's no water flowing through.
Are they, you base this on the 14,000 cubic feet per second, and you're trying to shave that peak because of the slope in the Makiki, the lower watershed?
Yes and no. The 14,000 is kind of the first number that the Corps gave us as extra water. We looked at how much we could remove if we were tapping off of a 20-year storm and taking everything above that, and that's what we're pulling out. So we're leaving some of the flow in to be equivalent to a 20-year storm so that we don't disrupt the wildlife, if you will, in the stream and allow it to flow normally other times.
Okay, let me just very briefly tell you about what we know about the EDR modifications that the Corps has put together. First of all, I want to say we have not seen the EDR. I don't know if anybody here in this room has. These modifications are based upon what we were told by the Corps. And so basically at a high level, what they're doing is they're removing debris and detention basins. They're adding a woodlawn bypass feature. They're consolidating 2 pumps into 1 pump station at the canal. They have modified the detention basins at the golf course and at the Houston Basin. They've added a Makiki Stream diversions feature, and they're putting up some high walls along some of the portions of the LOI Canal. And again, this is just what we know. We don't know any more than this. So I just wanted to kind of pass that out to you because this is what we learned from the Corps. What does the Corps need to do at this point? First of all, they need to complete and publish the EDR document. I understand it is still internally being reviewed by the Corps on the mainland. And I was told by the Corps that this is not a decision document. So this is basically just a document to document where they are. What they do need to do is a validation study and a supplemental NEPA before they can proceed on. Let me talk very briefly about the state of the current EIS now. This is the one that was issued in 2017. This has to be done so that work on the EDR features can begin. At this point, OEQC has published the EIS on the 23rd of July. Okay, for the next regulatory steps, the Corps needs to prepare a supplemental NEPA for the EDR. One of the things that we feel very good about is the Corps has acknowledged the value of SWIFT, and they are willing to look at it as a value engineering study and possibly include it as a betterment in its supplemental NEPA. And what is happening here with the PIG is they are encouraging the production of an EIS to include the SWIFT tunnels with the features of the Corps' EDR. And then from here, where do we go from here? We need to, at this point, get a copy of the EDR when it becomes available, and we definitely like to have the computer model so that we can start working on seeing how well we can get SWIFT to fit into it. I'm very confident that we are able to do that, but we need to get the models first. And when we do get that, we can validate a lot of data and a lot of the models that we have been working with over the past few months.
I do real quick want to clarify something that you all said on a few slides ago about the USACE plan. And you have the information correct, but the way it was delivered, it confused me. So I want to make sure that it didn't confuse everybody else. And that is the change in modeling results from the future without project conditions showed more water in the UH area and the Makali-Moiliili area. And so that's where one of the driving factors for our recommended changes. And to answer the question about what is an engineering documentation report, this Congress authorized this as a system, not as a single project. And so in order to make a system work, you have to, we had to make changes to the system features. And so the EDR captures our recommended changes to those system features. And then we just presented that. We presented it the first time 10 days ago, and we presented it again last week on the 23rd to our Washington vertical team in Washington, D.C., and we're awaiting concurrence from them so that we can release the modeling as well as release the actual document. And as soon as that happens, like I told Sydney this morning in an email, we'll do a press release as well as we will publish it on our website. And I'm happy to field questions. And as soon as I can release that document, I've already briefed the permitted interaction group on it. Oceanit has been a part of all of our executive leadership team meetings where we presented it. We're not trying to hide the information, but we can't get ahead of our leadership in Washington, D.C. to give us concurrence to move forward with our recommended changes. And so that's where we stand. We were hoping to release it this week. It's still possible, but again, we're kind of at the mercy of getting their concurrence. And with that, I'll answer questions or provide additional clarification.
Thanks, Jeff. I just had a quick question about that. So when you mentioned the modifications or the your suggested changes and not wanting to get ahead of Washington, you're talking specifically about those ones in the EDR modifications, but they do not at this point include anything that we have been talking about today as far as what Oceanit's been and the SWIFT tunnels. Is that correct?
That is correct. So Oceanit with the micro tunnels, the SWIFT tunnels, we're both working on the same thing, and that is pieces to the comprehensive flood mitigation issues. They're focused more on the upper watershed, where if you all recall, I suggested that we remove all 6 of those upper watershed detention basins. Specifically in Manoa, it was because there's so many sub-drainage basins down below Manoa Valley District Park that by addressing it in the upper watersheds, we weren't having the benefit in those lower areas. So we moved our focus down to the Woodlawn bypass and below, and so that way we could focus on the UH campus, the Makali-Moiliili. In our updated EDR, when you see the published results, you'll see that floodwaters in Makali-Moiliili during a 1% event have been reduced down to 2 feet or less, which if you're familiar with flood insurance and FEMA, that's a significant difference and impact, as well as in the UH at Manoa campus area. We've all but removed that water in that area. And that's with that Woodlawn bypass and with removing those upper watershed detention. And as I told Sydney this morning, and as I told the permitted interaction group, the 6 upper watershed detention basins have been removed from our recommended plan. The Woodlawn bypass is included. Down at the flood walls, I'm not sure the definition of high flood walls, and everyone has their own definition. I will say that with our consolidated pump station, we've removed a full half mile of flood walls from Seaside back to Kapahulu on the Makai side, no longer has any flood walls, and it's because we've consolidated the pump station up at the confluence of the Manoa and Palolo Canal. And then there are flood walls from there down to Ala Moana Bridge And because of the way the water flows and the way the pump station will pump the water out, it will be a gradual decrease in flood walls from the pump station down to Ala Moana. And we do not have those exact heights yet. They could be stem height up to 5 feet at the pump station. But based off of the foundation, we may actually recommend putting fill on the Mackay side of that flood wall. And on that fill, you'd be able to create an elevated path or a walking area or a grassy area. And so it would even appear smaller than that. That's what I've briefed many of you at all of our stakeholder meetings. And what I told you we were recommending is what we recommended. I just can't release the official document until I get that headquarters approval.
And then will you have to then reincorporate this this idea of swift tunnels in a new EDR down the road? Because it doesn't seem like if you're having a validation study based on what you've submitted in the EDR, that if you haven't included that inside of there, or maybe I don't understand it exactly, that at that point of a validation study, you throw in all kinds of different new ideas, or
They're two separate pieces of the puzzle, and I think Sterling's going to get into this in just a few minutes. So similar to if we do reforestation up in Paradise Park, that wouldn't have to be incorporated into our NEPA document or into our project because they're just separate pieces of the puzzle. What we would do is if we were sure that the SWIFT was going to be incorporated in, then we would combine the modeling and then we would adjust our feature heights and capacities downstream. Because as Sterling said, even with SWIFT, you're still going to need flood walls down at the canal. You're still going to need the golf course to serve as a multi-purpose detention basin because you still have that steep geographical change from Woodlawn Market, Manoa Marketplace down. So our features will still be necessary. But if SWIFT is incorporated, what it would do is it would potentially reduce the capacity or the height or the need for those features downstream. So it would not necessarily change our NEPA document and it would not change our study because it would just be less impact to the project.
okay, thank you.
I have a question for you, Jeff. What happens if your head office doesn't concur with your EDR? What happens then?
That's not no, that's not at all the possibility. The only result other than a concur and move forward would be them telling us that based off of the amount of change, they would require more in-depth study. And if they require more in-depth study, then it would require a new congressional authorization and it would require it to go back to Congress. There is no scenario where they say, we do not concur, go back and build the original plan, because we have proven, that's the point of this EDR, to prove that that feasibility plan was not a successful plan, and that in order to meet Congress's intent, this is what we need to move forward with. So they will either concur with that or they will tell us, we think we need more in-depth study and we need a new congressional authorization. Those are the only two paths forward.
Hey, Jeff, this is Mike. Knowing the budget that Oceanit just presented for these tunnels, is it in the ballpark or out of the question or realistic for this to be fit within your budget?
So I will be upfront and honest with you all, and I've had this conversation with the PIG and with Oceanit. At its current price, at its current design, it does not fit within the federal budget. And that is because it still requires so many features downstream. But that does not mean we can't incorporate it. It would just require additional funds from a non-federal sponsor. And I think that's a question that would go towards Oceanit or the PIG. Now, the way it would fit in the federal budget is if we do a value engineering study, which is required, and we identify that a portion of the watershed, a smaller swift tunnel could be incorporated somewhere in place or in lieu of one of our features. So if you do the swift tunnel down closer towards Kaimuki High School, just as an example, and you get it out there, and that cost is say 100 million, and that could alleviate a portion of the flood wall that goes from the confluence up to Date Street. You don't need that anymore because now you have a swift tunnel. So it's a one-for-one exchange, and it fits in the budget. But I will tell you, and I'm just being honest, and I've been honest with everybody up front, is that at 260 million and the need for the features downstream, it does not fit in the federal budget without additional money from the non-federal partner.
There's a question about the albizia trees and the impact it had on the Halloween 2004 flood event. We talked a little bit about that, the weir with the maze so that we don't allow the trees to go into the weir, and we have a grid over the top of the tunnel. Why not get cost estimates for 3 tunnels? In looking at the HECRAS models, the third tunnel being the Makiki tunnel, and looking at the HECRAS models, it did not have that big an impact. The cost was too great for the benefit to be realized. It almost had no impact, and there's other things that can be done for less money to address the Makiki area. How high are the walls? Jeff talked a bit about that. It's not known at this stage until they do more work. What is the additional cost of the core portion of the EDR? Jeff, I think that was somewhere around 375 million.
Total.
Total for the EDR features. How deep are the tunnels below sea level at the coast? About 40 feet. Would you be able to fully empty the swift tunnels between storms with no pumps, or would some amount of storm water remain in the tunnels? Potentially, a small amount of storm water would remain in the tunnels. The flapper valves would go down. Not all of it would be vacated, and it would be like a P-trap. There would be some small amount of water in there. The tunnel wouldn't be full. There'd be a couple feet perhaps of water, and over time it would evaporate until the next storm. Any chance, realistic chance, that any of the ecosystem community solutions will be implemented? I think there's a good chance for some of them. It's going to take more money. Jeff had talked about the ability to be able to look at ecosystem as a value engineering study or option. We will come up with, work with the Corps or with the tunnel boring people and ask them to give us a price to connect the Pololo tunnel to the Kapahulu into the canal, with the idea that we can reverse the flow of pumps, and we could bring in fresh water from the ocean during non-storm periods, put it in that into the canal and let it run down through the canal. And then with some of the Ken Kanashiro's ideas on Genki balls and some of those other things, I think you would definitely see a favorable result from that. What is the impact on groundwater cesspools and lava tubes of the swift tunnels? The tunnels are all going to be lined with concrete pipes, 12-foot diameter pipes. So once the storm water starts to go through there, it shouldn't have any impact on groundwater, cesspools, or lava tubes. Approximate maintenance cost of the tunnels per year. I don't have a number, but it's minimal. There's no moving parts. You just trim the grass, take anything, any loose debris, and ensure that the grates are open. It's going to be minimal.
I'd like to address 2 things. Number one, Dave Watassi's question about the storm surge and the coastal storm risk management. That is absolutely a concern of not only the Corps of Engineers, the state of Hawaii, and the city and county of Honolulu, but we do have authorizations for that. However, it did not fit within the authorization that this project was done under. We would need a request for that specific authorization. And then in reference to all of the ecosystem restoration opportunities, Oceanit back in 2008 to 2012 put a lot of effort into it. We still have those. And I've also seen Dr. Kanashiro's proposal for the albizia trees. And so what we need is, and it has to be a priority for the city and county and the state. And I understand that, and we all understand that they are wrapped up in other things right now. But as soon as we have an opportunity to get a letter of request from them to incorporate and study those for projects, then we can move forward under our ecosystem authorities for those two answers. Those are the two I wanted to touch on.
Well, at this point, Councilman Fukunaga, would you like to bring up the resolution?
Good evening, everyone. The last portion of tonight's agenda is really going to be focusing a little bit on some actions that the PIG and the PIG consulting team will be pursuing. We recently introduced a resolution signed by all three PIG members, council members Kobayashi, Waters, and myself, which will expand the scope of the permitted interactions groups jurisdiction to issue interim reports as may be appropriate within the next couple of months. You know, if we were at a point where we would be able to issue a final report, we would be very excited to do that. However, we know that, you know, some of the issues that remain to be addressed also include further evaluation and analysis of the features of the EDR recommendations. So this resolution is online. It's resolution 20-179. And the way that these types of resolutions work is that we would put this resolution before the city council. You know, we are not in a position to take action or make decisions. We provide information to the council. So by allowing the PIG to issue interim reports, we would be looking to work with our Oceanit consultants to come up with a preliminary report based upon a lot of the information that has been covered thus far. And we hope that that will help inform a lot of the dialogue that we hope will take place over the next several weeks. So that's pretty much what we have on top of the resolution. Are there any questions that you have? Okay, if not, this resolution will probably be forwarded for the council to consider at the August 12th meeting. So, you know, if you do have questions, please get back to us before that time. And I'm going to check to see whether Councilmember Waters or Councilmember Kobayashi have additional comments. Okay, Councilmember Waters.
I do. I actually, Jeff, can I ask you a question? You said that the city would have to do a letter of request in order to include other possible solutions. So where would that letter come from? Is that coming from the mayor, or could the city council through resolution request? And could we simply request that you include Swift technology?
So, Councilman, I apologize that I wasn't clear. Specifically for coastal storm damage and the tidal surge that Mr. Watasi was referring to, and specific to ecosystem projects such as the reforestation in the Paradise Park area that Dr. Kanashiro has proposed in the past, those would require letters of request from a non-federal sponsor. And there's lots of definitions from that, sir. And I'd be happy to share that with your staff as to who qualifies as a non-federal sponsor. And I think I've shared that with Oceanit in the past. So I do apologize, but those would be for other authorities that the Corps has separate to the flood control authority that we're operating under.
Okay, shucks. But ultimately, I think we all want to protect the entire watershed. And we all want to do it in such a way that's acceptable to each and every one of our communities. I hope that the Army Corps adopts the SWIFT project into their plan at some point. You know, I think the community doesn't want detention basins. We don't actually want large walls either, if possible. And I think that's partly why we want the SWIFT adopted, because I'm hopeful, based on what you're saying, Jeff, that perhaps the SWIFT could bring about changes so that we can eliminate some of the other, I guess, solutions. But, you know, thank you all for participating. Thank you to Oceanit, and thank you, Jeff, for participating. I'm so happy that you were here to hear what the community had to say. And thank you all community members for taking time out of your busy schedule. We really appreciate that. At this point, unless anybody else has any comments, any other council members, I think we're going to close the meeting. Aloha, everybody. Thank you.
Thank you very much. Thank you for coming. And again, if you have any questions, please feel free to send it to our email. It's alawai@oceanit.com. I think the slide was up a little bit earlier. Again, that's alawai@oceanit.com. All right. Thank you very much.